I'm Phil, Head of Partnerships here at OKdo. Hope you're doing okay. I've been with OKdo for about 3 years now. Prior to OKdo, held a few positions in technical roles, whether that was R&D of designing hardware, also in the applications area, helping customers integrate products into their end devices. So that hardware role would have included working on cellular platforms, Wi-Fi, and integrating those into PDAs, which are now known typically as smartphones. Also had a few positions as software engineer, both in R&D and again, application support. So working on protocols and integrating products into devices, whether that's things like smart meters, vending machines, smartphones, and other products. So some of the wireless technologies I've been involved with: cellular, Wi-Fi, FM, transmit and receive with RDS protocol stacks on as well, so you could send information across the air. Bluetooth Low Energy. One of the things I worked on a while ago was being able to position where a device is using the signal strength of a Bluetooth Low Energy radio. But then the question is, if the device knows where it is, how can that send the data out? These days, as we saw with the track and trace apps, you could even use the Wi-Fi or the cellular backhaul to get the data out. But decided to work on designing a mesh network, which is now known as Bluetooth Mesh, NFC, and a few other radio technologies in there. Now, as a design engineer in hardware, one of the things you often get from a silicon vendor, let's say it's a processor board, is a reference design or a development board. And that would often have the system on chip, silicon chip in the middle there, and loads of I/O capabilities around the outside of that board. So when I'm designing an end device, I'll be able to experiment with this development board and then create my own schematics and Gerbers for a customized, bespoke, cut-down design. That dev board is then used by countless other engineers, other companies, other products, and they would then use the same hardware to experiment with it and cut it down and optimize it for their end products. So around 10 years or so ago, single board computers became very popular. A single board computer has similarities with a development board. It contains the main processor, typically some memory on there, possibly Wi-Fi chips, Ethernet, and it's a whole computer subsystem ready to go. And a lot of engineers take that as essentially a system on module and integrate it into their end device, and therefore they can create a product very, very quickly. Let's take an example of, say, a barrier, a car parking barrier. Now, the engineers that create those, they understand how much torque needs to be applied to that lever, the strength of the motor, the gears, the mechanics behind it. But they probably don't want to be diving deep into the electronics, the memory buses and the Wi-Fi protocols and power supplies for the control system. Wouldn't it be good if they could just take an off-the-shelf computing device? So single board computers fit that bill very well, and they can just write the basic software on there and it will control their end device. Now, at OKdo, we've been working with a lot of industrial professional customers over the years and been listening to their requests and requirements. And we've come up with a solution with our internal engineering team and our partners that create single board computers. And the first one I'd like to show is the Rock4 SE. So it comes in an anti-static bag. We'll revisit this in a few moments. And this takes a lot of the learnings from the SBC history that we've got and it integrates all sorts of new features on the board. So let's go for a little walk around the board. Down the bottom here, you'll see there's some pins. This is for power over Ethernet. Then you have the 40-pin header here, which is actually color-coded. And I've used, when I've been experimenting with this board myself, I've actually used this color coding a few times without having to refer to the datasheet. So small things like marking out where the power and ground lines are can really speed up the prototyping work. Up the top here is a Wi-Fi and Bluetooth combo module. This supports 802.11b, G, N, and AC, and Bluetooth and Bluetooth version 5, Bluetooth Low Energy, and then there's the antenna at the top here. You have a zero insertion force connector here. This is for an external display. So we find in a lot of industrial type applications, customers put a display over the top of the board, and they can use that as the control panel. Then there's the USB Type-C port. This USB Type-C supports power delivery and quick charge, PD and QC. One of the learnings that we've had is when our customers are using single board computers, a common complaint that we've heard is that the board is unstable, or they see low power warnings on the screen. PD and QC can negotiate with the charger to find a voltage difference of 5 volts, which is typical for USB. And this negotiates up to a higher voltage, therefore less current is required on that port. So there's a lot more headroom here for the board to use before it goes into low power warnings. Next on there's actually a small footprint, which is space for a digital microphone. It's not fitted, but it's a configuration option that can be added to the board. Of the full-size HDMI port, that's 4K 30 frames per second. And then there's another zip connector here for a camera connector. Next to that is a 3.5mm audio jack. This audio jack supports stereo out, but also microphone in. And again, another learning we've seen over the last few years with homeschooling and working from home. People want to run Zoom calls, Teams calls, but without having a microphone input, that has been a bit awkward. Then there's the gigabit Ethernet ports, and we have the USB ports here. So there's 4 USB ports in total. The 2 black ones are USB 2, and the blue ones are USB 3. Now the 2 USB 2 ports and the lower USB 3, they're powered off of a single regulator. So in aggregate, they can provide 1.44 amps to a peripheral device. The upper USB 3 port is powered directly from a single regulator. So that could provide 1.44 amps itself to a peripheral. On the subject of the USB ports, right underneath the ports, there's a slide switch which allows you to configure the upper ports as USB host or on-the-go mode. So it could actually behave as a peripheral device itself rather than purely as a host. Now something else, if you take a closer look behind the USB ports, and say for example behind the HDMI port, they're very clear here, and they're dotted around the board in different places. There's one behind this USB 2 port here, is a set of components for ESD protection. Now again, the product comes in an ESD protected bag, and one of the things that our support team has noticed over the last few years is that some of the single board computers are coming back, working intermittently and not reliable. And this is perhaps down to ESD shocks, whether it's during build time and someone shocks it, not in an ESD safe environment, or something to do with the end equipment that it's being used in. So it comes with a bag for safety and also ESD protection components as well to help reduce any risks there. You'll notice there's no major chips on the front there. The main system on chip is actually on the back there, which makes it much easier to add heat dissipation technologies on there, heat sinks or fans or anything else if you're going to run it in high performance mode continuously. The system on chip is by Rockchip. It's an RK3399-T. This is a Hexa-core processor which contains a dual-core Cortex-A72, typically clocked at 1.5 GHz. It's got a quad-core A53 processor on there, and that's clocked at 1 GHz. There's also, if you read the datasheet for the Rockchip, 2 Cortex-M0 processors in there to support the main Cortex processors. There's also a quad-core Mali T860 GPU in here. And coming from a mobile chipset, as you'd expect, very, very smooth performance on the user interface, arcade-style graphics. This GPU can support OpenGLES up to version 3.2, DirectX 11.1, and OpenCL 1.2 standards. So with OpenCL, you can run parallel compute type applications on the GPU, not just on the CPU cores. There's two large black chips here. These are LPDDR4 RAM. It's 4 GB and it's dual channel for higher memory bandwidths. Around to the side here, there's a port connector for external power. So that can provide power to the real-time clock on the board. It can also derive its power from the USB input as well. One of the great advantages of having a real-time clock on here is that the processor can set an alarm signal on the clock. When that expires, it will wake up the main processor from deep sleep, which is extremely low power, continue processing its tasks, and then go back to sleep with another alarm so it wakes itself up at the appropriate time. Now that would allow applications perhaps battery powered or much lower power consumption in long running type tasks. Another request we've seen many times from customers is to add an M2 slot or some way of adding large external memory, perhaps for a NAS drive or a media server. So with these M2 slots, we can add large amounts of disk storage space with ease. There's also an SD slot there, typically used for operating system storage. But actually, the system on chip provides support for 2 SDIO ports, which is SDIO version 3. One port of the chip goes to the Wi-Fi part of the combo communications module, and one goes out to the SD slot here. There's also support for eMMC memory through these connectors here. This is another common request we've seen from our customers, where boards are often located in remote locations and hard to reach. So one of the things with an SD card is that they can wear out and become corrupted. If that happens in a harsh environment, then it's very hard to maintain the board. So eMMC offers a fast and reliable alternative to SD cards. So that's a quick overview of the ROC4 SE. So as we've discussed, this is a highly configured board with so many different options on here. But you'll notice that, for example, the digital microphone, that part isn't fitted, but it's a configuration option. There's also a space behind the chip antenna for an external antenna connector to be fitted. But again, that's not fitted. So there is configurability built into this board. And coming from hardware design engineering days, with a development board, you're probably not going to want to use all of those components in every design. So although this board has everything fitted to it, we're happy to speak to you and get our engineering team involved in our new configuration service. So perhaps you've got a use case that may not want to use the external M2 memory card. Or let's think about the use case we spoke about earlier on of the car barrier. In that use case, they're probably not going to use the HDMI port. They're probably not going to use the display or the camera connectors. I doubt they're going to use audio in or out connector. Probably never use the USBs or the Ethernet. Wi-Fi, unlikely to be used. They're using it purely as a control board. So, as with any hardware design, we'll be able to remove those components and reduce the cost financially, and also the any waste products of this for the planet as well. So, if you want to have a custom board with more options or less, please reach out to our sales team or contact us via the website, and the engineering team will be more than happy to talk you through what is possible. Thanks for watching.